Good morning, students. You are welcome on the day Tuesday, 7th July 2020 in class physics 10th BT, PTB. And today our topic is sound intensity level. Once again, I'm going to revise the definition, the intensity of sound. Yesterday we learned it. Sound energy passing per second through a unit area held perpendicular to the direction of propagation of sound waves is called intensity of sound. We learned that whatever the amount of the sound energy passing through a unit area means length, width, and height of that area must be the same. Unit area 1 meter long, 1 meter high, 1 meter breadth. So, such type of the area when the sound energy passes from that unit area must be held perpendicular, mean at a right angle. So, whatever that amount pass through the unit area held perpendicular to the direction of propagation of sound waves is called intensity of sound. And we studied yesterday that the unit sound intensity of sound is a physical quantity, therefore it needs to measure. SI unit for intensity of sound is watt per meter second per meter square. So today we are going to study the topic sound intensity level on the page 24. It is better that you, all the students, please open your books and look on the page. The human ear responds to intensity range. Reaction or the response of human ear. One is the minimum and other one is the maximum. The intensity of minimum, that is, we represent by the minimum intensity loudness of sound, that is L naught. Because we have studied intensity of sound, it depends upon two things: loudness and the sensitivity of the ear of human, the health of the ear of human. So L naught is the loudness, that maximum and minimum. L naught represent the minimum sound loudness and L will represent the maximum loudness. So L stands for the loudness. So intensity level for the human healthy ear is 10 raised to power minus 10 watt meter per second. It is the faintest sound that human ear, healthy ear, normal ear can respond. And this maximum intensity loudness level is 1 watt meter per second. This is the very, very high level, and it gives the pain. It is painful. So, the reaction, human ear response for the range of minimum loudness and the maximum loudness. This minus 10, 10 minus 12 watt meter per second, and maximum is 1 watt meter. So, loudness L, it is proved by the study that the loudness of the sound is directly proportional to the log of intensity of sound. I mean intensity, and L you already know studied that it is loudness. So loudness of the sound is directly proportional that log of intensity. So if we change this relation into equation, we write it L is equal to K log I. K is the proportionality of constant. You know that when we change any relation into the equation, we introduce a K as a constant. Anything as a constant, in different equations you may have studied a different constant. In last chapter, you studied about the Planck constant. So in this equation, we introduce K as a constant. Now, the difference, if L is equal to K log I, it means this is the maximum range, maximum loudness. And if it is the lowest, the faintest loudness, then the same equation will become L naught is equal to K log I naught. Rest of the equation will be the same, only the loudness level will be changed. This is for the maximum, and this stands for the minimum. And intensity of maximum sound and intensity of lowest sound. So if this is equation 1 and this is equation 2, we can find the difference of intensity level of both, the difference of sound intensity level. This can be written by the subtraction of the second equation from the one, the difference of both. You know that how we can find out the difference. The maximum subtraction or the minus lowest. So the difference of the sound intensity level, it is L minus L naught. It will come by subtracting equation second from the 1. K is the common in both, so log I minus log I naught. This difference is called sound level. K, and you have studied the logarithm in class 9th, that this subtraction can be changed into division. So K log I divided by I naught. Bell. Bell is the units. You may have hear the name of Graham Bell. Graham Bell was a scientist, Alexander Graham Bell. So this is the unit of sound level, intensity sound level, but this one is a very big unit. We use the small unit, that is decibel. Bell will be changed into decibel, and 1 bell is equal to 10 decibel. Therefore, we put here the 10. K is equal to constant and it is equal to 1. K is a constant and is equal to 1. So therefore, we will put the value of K, that is 1, and there will be no more K here. So 10 log, rest of the equation will be the same. Only the bell will be changed into the 10 decibel. 10 and decibel comes here. So 10 log I over I naught. So this will be the equation that we change this equation, the bell and decibel, into convert into the decibel. The value of K depend not only on the unit of I and I naught, but also on the unit of intensity level. Look please on the page 25, the second paragraph. For your betterment, I'm going to read a small paragraph. A value of K depends not only on the unit of I and I naught, but also on the unit of intensity level. If intensity I of any unknown sound is 10 times greater than the intensity I naught of the faintest audible sound, that is I, will be equal to 10 I. So therefore, we change here the bell into 10 decibel, because I told already that the bell is a very big unit and we change it into the small unit, that is decibel. Thank you and God bless you, students. Tomorrow we will again see each other. Thank you and God bless you again.